In this video, we're going to go over the Riparian Function Assessment tool. This tool will determine site-specific riparian buffer designs for each riparian catchment. The designs are based on a cross-classification between two variables, the runoff delivery, which is calculated by the riparian catchment size, and the denitrification potential based on the water table depth, and then will be extracted from the height above channel output. The tool is going to run through a set of criteria within the riparian zone, which is defined as an area within 90 meters of the stream. An identity is performed between the riparian catchment and stream channel, and then a 90-meter buffer is made for each stream section. And along with additional processing, we ensure that there's no overlap between these riparian zones. Once the buffers are generated, we assess the two variables within them, and that is the runoff delivery and the denitrification potential, to determine which riparian buffer design would be most suitable for that area. So let's go ahead and run the tool. We'll come over here to our toolbox and open up the Riparian Function Assessment. And we see that we have 3 inputs and we'll get 1 output. The first is our stream reach. Again, this will be the same stream reach that you use to generate your riparian catchments. The second input is the riparian catchments themselves. And the third input is the height above channel raster, which will be used to determine that water table depth. Our output is the riparian function table, and we can use this later to join to our other feature classes that we've already generated. Alright, everything looks good, so we'll hit OK, let it run. Next, we need to assign a denitrification rank and a runoff rank before we can begin our cross-classification assessment. So for the denitrification rank, we look at the low-lying land's average width within the RAP. If that average width is greater than 50 meters, we assign a rank of high. If it's between 25 and 50 meters from the stream, we assign a rank of medium. And if it's less than 25 meters from the stream, we assign a rank of low. Next, the runoff rank will be assigned to the RAPs. So, areas that would convey half the surface runoff from the watershed that flows through the RAPs to the stream, considering if all areas were to generate runoff equally, would receive a rank of high. RAPs where a buffer occupying exactly 2% of the total contributing area to the RAP would be wider than 10 meters receive a rank of medium. And a 10-meter wide or narrower buffer that provides a minimum recommended buffer area ratio of that 0.02 or 2% receives a rank of low. So that 2% buffer area ratio is what's generally needed, and this is recommended by NRCS. The buffer area ratio is calculated by taking 2,500 divided by the contributing area along those bank cells within a RAP. That 2,500 is equivalent to the area of a 10-meter wide buffer along that 250-meter long RAP. And so basically you can see down here that if that buffer area ratio is less than 2%, median runoff rank is assigned, and if it's greater than 2%, a low runoff rank is assigned. Alright, now that the tool is finished running, we can go and look at our output, which is this table. This table can be joined to your riparian catchments or your riparian attribute polygons by the riparian ID field. So to do that, you would right click onto one of these feature classes, go to joins and relates, join. You would select the riparian function table and choose to join by riparian ID. You see that this field fills in down here, and you'd hit OK. I'm not going to do that right now, but just to show you how it's done. In this table, the stream segment length is carried. The straight line length is also carried. The acres of that riparian catchment is there. We have the average width of a low height above channel elevation, and that's less than 1.5 meters within the riparian zone. We have the Ratio of the area of a 10-meter buffer divided by the local runoff. We have the actual runoff rank, the denitrification potential rank here, and then we have the suggested buffer design based on that cross classification of these two fields. And then finally we have a suggested buffer width according to NRCS, and this is in meters, and then we have an ACPF suggested buffer width. Alright, so now let's do some symbolization. I'm going to turn off my height above channel and join that table to my riparian catchments feature class. I'll then go into symbology, and by categories, let's do by riparian function, add all values. These null values are going to be the headwaters. Remember that they do not actually line a section of stream segment. Let's just symbolize these. Real quick. And you can symbolize these however you would like. Apply. Okay. And so now at the catchment scale, we're able to see what riparian buffer design would be most suitable. Here's a brief recap on the riparian function assessment tool.